Okay, we're back with more DSPy today. Hopefully no more Windows hiccups this time. So let's go straight into it, pick up where we left off, which was last time we had this. Let's see, what did we do last time? So we had oh, here it is. Okay, so we wrote this module with 2 inputs and 4 outputs, right? If I remember correctly, yeah, 2 inputs, 4 outputs, and it was a generic problem solver that takes as input the problem description and a list of numerical cases, so matching inputs, outputs, and then had 4 outputs. And one thing we saw last time is that there is a problem when trying to sort of reuse the solution of one output in the other, because somebody would have to write those prompts, and we definitely don't want to write prompts because there's too many outputs, so it becomes hard to keep track of everything we write. So instead we said, let's do these custom fields that have 2 more attributes found that well, actually these are functions in DSPy with 2 more arguments found that and depends on, and let's also write a custom adapter that looks at these arguments of fields, of field functions, and automatically writes some prompts, for the LLM to properly reuse, in this case, Python code from other files. Because another assumption we have here is that each of these 4 outputs lives in a separate file. So that's where that's what the found that field tells us, and depends on tells us what previous modules or files, Python modules, should this output module import. And then this translates to basic prompts like this one. When generating code for the current module or field, use the following import statements from other outputs. And the import statements have to read something like from a relative import in Python and import the function name. Okay, so let's see. We have our little, we have our to-do app here. And what would be nice to start with is to let's see, so yeah, use correct absolute imports. Okay, so basically finish adapter. Then what we want to do is modularize all the new let's call it adapter in a new file. So we want some clean code. Before that, we want to modularize the entire project. So this means like a main, etc., args, etc., because we're gonna do some trickery. And we'll see if we get to this. Maybe you can guess where I'm going. Why would I want all of this new things in a new file? And when I say new things, I mean all these things that generate Python import statements, right? Yeah, so modularizing interpreter. Maybe we also need a data class. for the entire file system. Okay, so another issue that we have with the current version is that we have to specify for each field where is it found and what does it depend on. The where is it found part is fine because that's a linear number of specifications. What it depends on is not really fine because it's a quadratic number of specifications, right? Because in this case we wanted the test code to exercise to actually test the solution and also run this time and memory complexity measurement code. So I think a more principled path is to specify the entire file structure beforehand of the project. And maybe use some attributes here, but that still requires defining everything by hand, right? Doesn't seem like there's any way around that. Okay, so maybe this is not too important. Okay, so let's start again with the environment. So we always do UV sync. Okay, the environment is good. Do we have any breakpoints? Okay, so the very first thing we need is, I want to turn this off because I want to regenerate the old output, and we lost that thing. We lost this capability, right? Because of the new fields. So I guess the most basic thing is, let's do some args. And let's start with modularizing then which item was that? Yeah, so let's first modularize the entire project with main and args. I think this is gonna help debug through. Okay. Let me see what's happening here. Okay. Okay, the only thing we need there is how to use argparse, which I don't really know by heart, but that shouldn't be the problem. Python argparse example. Okay, there we go. We just need the basic parser. And we should do this in the main actually, right? So we need a define main. Sorry, it's not like this. It's if name is main. We can do the args here. So we get the args and we call the function, which is called, let's call it main for now. Okay. And then we just need to turn all the main level code, which is not that much, into a function with args. Okay. Args. Maybe I should have used fire for this, but it's fine. And I think it was add. Yep, there it is. Add argument. Okay, so first and foremost, we need the most basic argument, which tells us whether we use the vanilla DSPy or the we need a boolean, which tells us whether we use the vanilla DSPy or our new our new fields. And how do I do a Python boolean arg with default false? How do I do this? False. Arg parse. Okay, so it's just enable feature. Okay, so if the flag is not present in the command line, okay, so then we just need a basic boolean. Okay, this is good. Let's see, so enable, what do we call this? File system. Or let's just call it file system or files. Use file system aware adapter and fields and signature. Okay, and we call it with args. We have to write the logic for args.files now. This should be pretty easy. Oh, there it is. So adapter is what's the default here? None. It was chat adapter, right? I think I remember that. So it's chat adapter. Well, no, let's do it the other way. File adapter args.files else chat adapter. Okay, and where do we get chat adapter from? Somewhere. From, maybe it's even here, from DSPy. Yeah, it is here. Okay, chat adapter. Okay, so this is the vanilla field, the vanilla adapter. Okay, good. And we just need to pass adapter. And we also need field function, because it is a function. Well, actually, it's output field function, right? So this is going to be output file field if args.files, else we go back to the vanilla DSPy output field. Then we just call the function, and this is fine because these will be quargs. And hopefully there's no pydantic collision here, which there shouldn't be. And I think we're good to go. This should be it now. Yeah, so let's run, good. So now let's run the solution again, because actually there's something else I wanted to. Oh yeah, another thing I wanted to do is to add a linter, because it's bothering me. So let's look a bit at rough. And how do we... Yeah, this is what I want, right? Extremely fast. How do we install this? We don't need to install because we can just use it with UVX. Or we can install it as a UV tool. So let's see, what if we do UVX rough check? Pretty nice, yeah, okay, so UV allows us to oh, I see, it's giving us errors. Oh, of course it's giving us errors in the, interesting. in the generated code because it's also Python, but I actually want the format. Okay, good. So it reformatted. Now, interesting, I want to, okay, so this is a good thing to remember. We may want to exclude generated code from rough, because this doesn't seem like, unless we know what we're doing, this seems pretty dangerous, right? Because it's gonna mess with the AI written code. I don't think we want that, actually. Maybe not yet. Yeah. Okay, so we have main, we have args. I think this is it for modularizing. Let's remove the breakpoint. Well, not that we need it, and now we can just run UV run main py. That's it, and we're not using the flag, so this should be vanilla. Sorry, and that's good because I wanted. Okay, there we go. So now we have the solution. These are the solutions we saved last time. Sort of the failure cases, but now let's see. Okay, so now we also have the file structure. Let me look a bit. So of course the test has the leaky logic problem. Okay. And yes, it has double leaky logic problem, because what's happening here is that, oh my god, there's so much leaking logic, right? So remember, we have 4 out. Okay, so let's recap the problem that we're trying to solve here, because we have 4 outputs. Solution is the core code, right? So if you remember, the example problem here was counting the number of unique elements in an already sorted array, which is a very easy problem to solve. This code is correct. The problem is we also want the AI to generate 3 other pieces of Python code. Something that measures time complexity, something that measures the memory usage of the solution code, and some test code that tests the solution code with some numerical cases, and also exercises time and memory complexity. So the problem everywhere is that even if I look at runtime, there's no import of this function. There's a redefinition, and it just happens to be the same here because the LLM can do copy exact, but we don't really want this, right? We would like to reuse the same function to have, let's say, formal guarantees that we really are exercising that exact piece of code. And this is also going to save on output tokens, right? Because this code should be deleted, and this should just be replaced with from, I guess in this case, ... solution import unique count unique. There we go. This would be nice. So then the problem becomes, how do we tell the LLM to do these? We don't want to type these prompts, so we're just going to try to specify a file structure and automatically generate these prompts, and also mitigate the leaky logic problem. And then there's double leaking logic here because the test code, actually there is the test code that's supposed to use the run, the time measure, for example, doesn't do that, and it just does some measurements on the fly, which again, there happen to be the same here, time.performance counter, but we should have just imported this time measure function and run it. Same for memory. Actually, I wonder if memory is the same. Memory is not even the same. I see. So this is for a specific case, whereas this is for everything. Okay. Trace malloc. Yeah, so the pieces are kind of there. I mean, the model can stay consistent here, even though it's leaking logic. You would be tempted to say it's fine, but it's kind of really not, right? We really don't like this. We should just have the model do import statements, because then we would have guarantees that whatever code is in solution is also measured and exercised. Okay, so let's go back to the code now. So for that we added, okay, so now we are in vanilla mode. Actually, I did want to, let me try this again, because I wanted to exercise another failure. We saw it do something weird about the measurements last time, where it was not even measuring things, it was just outputting hard-coded strings. Okay, this is a hard bug now, because in this case it forgot to even import. Very interesting. So this code won't actually even run. It didn't even leak the logic, which is a symptom of a weaker model. We're using the Qwen NVIDIA one, but still. Not Qwen, I mean the Nemotron 30 billion, but still. Oh yeah, and there's a bunch of stuff here. There's peak, current, okay. Okay, so I'm curious, if I just run the test, does the test itself even run? So solution test. Yeah, it runs. Okay, so the test is always self-contained. Again, the test is leaking logic. Let me try again. There's another failure mode where again, this one we saw last time. I kind of want to capture that. Oh, this is an interesting one. So okay, so now this is the length of set solution. Again, this is not gonna work. Aha, okay, this one is even worse, because the model just forgot. Interesting. The model simply forgot to. So let's make, okay, so now we can do some prompting. Okay, so let's make this explicit. Runs time complexity and memory complexity measurements. Because we can't even get the test to consistently exercise measurements. That's a big problem. That's outside of the scope of what we want to solve. So that's something that's worth prompting for. That's a user error. Okay, so we got the good test now, which I'm assuming it's gonna work. It looks very complicated, but it works. Aha, here's an interesting one. Oh no, it's still the same, okay. But what is this? Measure memory of object? Oh yeah, this is a wrong measurement now, because, okay, this is kind of what I wanted to get. So the runtime is fine, but this... Yeah, so this is not really profiling, right? Because it's just doing the memory consumption of the Python object. In this case, what? The result of the time measurement? Oh, result of the function, I see. So very ugly. So this we also need to prompt for. So code that, let's call this profiles, the runtime, and profiles the memory usage of the solution. So let's call this of solution. I like to use this backtick thing where I address the fields by backticks. Let's call it runtime memory usage then. And let's call this execution time. This should be clearer now, because I really don't want to see that size of is really bad. Like it's basically measuring the size of the code, right? And we definitely do not want that. Yeah, the time is easy to get because it's counters. Okay, so it is a trace malloc peak. Ah, interesting. Another interesting failure now is that... Oh yeah, so no imported function. Also no imported measurements, even though it tries to exercise them. Again, missing import statements. And now we can see why this is hard to fix by hand. Because we're missing 3 import statements here from different places, right? It would be from solution import whatever, and then from solution from solution import from solution.solution, yeah, because that's a module, import the function name, and then from solution.measurements.memory import whatever. So we need to generate those import statements. So okay, so let's get back to the main thing now. Okay. Okay, so this is the code without our thing. Now to turn it on, we go uv run main, what we call the flag files. This is gonna crash now. Somewhere. Adapter.init got an unexpected keyword. I see. So we're not using the right adapter. This doesn't inherit from chat adapter. So we have a DSPy predict error now. Where's the adapter? Did I not put the adapter? Oh, I did use the adapter. Okay. And output field function, if args files, okay. This should be good now. So output field function. Okay, so we are right here then, right? Let's see what's happening here. Something bad is happening here. But this should be easy to fix. Signature. No, problem solving. Well, I guess. Found that. Path. Found that. Depends on. Okay, so these are all here. So who is yelling now? Adapter.init got an unexpected keyword. DSPy.predict. Line 192. So what is the adapter here? Good question. Settings.adapter. This should be our adapter. What? And it doesn't have a... Let's see. Is this our adapter? It should be file adapter. It is a file adapter. And what? It doesn't have... Oh, it's a class? Oh, I'm sorry. It's my bad. It's an instance of the class, not the class. All right. Okay. Good. That's pretty much the fix. Main files. Okay, this should work. The problem is the prompts are not good. We'll see. So this should really be it. I'm just gonna continue this run. Well, no, I won't. Okay. But the problem is the prompts are not good because they have weird dots. So the next item on the list was to use the correct absolute imports, obviously, because right now they are a mess. Okay, so it works. We can check the history. We can see here some of the prompts. When generating code for time complex, use the following import statements. This is not a valid Python code. This one maybe is. This one maybe is. I don't know. Let's see what happened. Yeah, so we kind of got Okay, so we're from .solution import unique k, which is the function name. This actually works. Oh, it doesn't. No, never mind. It's from. So we need to turn this into a proper Python module. It's not hard. Yeah, we're pretty much there. The model obeyed what we told it to. Interesting. There are cases too now here. Did I say to exercise on case? Ah, very good. Here's an interesting one because solution is a module. But some outputs, do they depend on inputs? Like cases is a what? Cases doesn't live in any file. Okay, we gotta be careful here. Interesting failure mode because it's referencing some mysterious cases and those are not outputs. So we can't put this here, right? There is no, our current file convention is only a graph between outputs, but interestingly, cases is an input. And it's not written in a file of its own, although it could be. It really could be, right? And we could generate an import statement for it if we had found that. So there would be a cases.py. And it will be from cases, import cases, the variable. Do we want to go this way or should we keep the graph? Another problem here is what if this would be a text file? Then we have a cross-language issue, which we deemed impossible. It's not really true. Tricky. See, even though this is a very simple DSPy module, some of these things can be tricky, which is kind of the point of why I'm blabbling about all of this. Babbling. I would leave it for now. Yeah, this cases is pretty sharp here because I can't even write this systematically to, well, I guess I can. No, I can't write it to Python because this is a Python. But actually, this is not even that easy to write as Python code, right? Inputs, cases, what do we have here? So basically, I would have to rewrite a file. Let's see how does inputs cases look like. Whoops. Okay. Ah, here's another problem because we assume signature output fields. Yeah. Oh boy, this is a whole different can of things now. I think let's do it. Let's give into feature creep. Let's just do it, right? Okay, so let's make this work with everything then. Fine. So first of all, the one trick here is that there's not that much difference between the DSPy input field and output field. Just the DSPy field type, literally. Okay, so we can just inherit, let's see, so input field fn. This is an input file field. If args.files else DSPy input field. Okay, so now we can use this guy. Okay. And we just have to define this input file field, which is exactly the same, very close to this, right? Quargs. And it's just the type input. Okay, this was easy. Now, careful here because we hard coded. So this is correct. We only want to generate the statements for the output fields. Depends on, info is fine. Depends on. Here it is. So for each dependency, so let's get the depth field then, right? So first is what do we have in signature dot output? What are those? Output field, input field. Are those signature dot input field, output field? Are those lists or what are they? Dictionaries? Oh, sorry. Yeah, so these are dictionaries. How do I do a union of two dictionaries then? Is it like plus? I think so. Plus. Whoops. Signet problem solving. Oh, I see. What? Oh, it's OR pipe operator. Okay, I see. Interesting. So this should be pipe then. Okay, good. All fields. All right, it has to be like this, and then all fields. Yeah. Okay, so we just have to reach into all fields. So then we say what? Actually, does this work? Pretty sure this doesn't work in Python, right? Cases? Oh, it does work. So I don't even need that. I don't even need the all fields explicitly. It does look ugly though. So all fields is signature dot input fields union with pipe with signature dot output fields. I'm guessing there's gonna be, if there's conflicts, it'll crash by itself, which is good because you should not have DSPy. Right? That doesn't make, I don't even know if DSPy even lets you do that, have two fields with the same name. That would be really dumb. Yeah, there's no way. I mean, I guess it can be if it's input and output. They are distinguishable, but that still sounds like a bad idea. Okay, so where else are we? Oh, I see. So here, all fields, annotations, language. Aha, now be careful here. We gotta be careful here because we may get an exception here. We may, I think text is fine here actually. So let's put a to do, maybe for later. Text could, no, anything could depend on text. Because why do I say this? Because reading from files is a very broad functionality in any programming languages. So it's valid to say that a Python file depends on a text file. It makes more sense than a Python file depends on code in a C file. That everything makes sense, but that one's a bit of more of a stretch. But text, I feel like we should let through. It's like a universal invariant, maybe. Maybe later though. We're not gonna do that. Okay, so what do we have here? So all fields. Okay. This should be it. Okay, so now we have, okay, good. So now stuff can, this is it. So cases is found at path. These guys depend on cases. And let's, here's an interesting one. So the reason why I was hesitant to do this is because these are now hard coded. Like you're sort of telling the model, okay, so we have to say this when running on cases, because otherwise it does become ambiguous, but we did just hard code this. Another way would have been to tell the model to just don't depend and implement cases in the API. But then telling models how to do function API is a whole different can of worms, which that's a good topic to talk about. I don't think DSPy has that. No, it doesn't have that because it doesn't even have the concept of function. So that's actually a topic for later in the series. But that's an interesting topic too, for sure. So, okay. Okay, so now only these guys depend on cases and they will be hard-coded. But then we say solution on provided cases. Okay, so this one also depends on cases. Nah, we can't get away with it, right? Because you have to test on the cases. Okay, fine. The only thing that's left though for the user is to write the cases to a file. And we can just write them. But how do we write them? This one is... because I can't just write... I have to write something bad here, right? I have to actually format this. Ugh, which is not the best. I have to say cases equals... cases. I mean, sorry. Pred dot dot code. Let's see if this is valid thingy. Let's see. Okay, we really need to fix those import statements though before. Oh yeah, this is not good because this is not Python code now. Oh boy. Oh boy, oh boy. We're in big trouble now because for dependencies we need. it's not even text though. It's actually, I forgot, it's directly a Python data structure. And this will always be a Python data structure. Well, it is text, but it's forced text. This one is tricky now. How do I depend on this? I can check if the other object, if the dependency is a code and its language is not equal to, okay, so this we may just, yeah, let's do it this way. It's a bit hacky, but then we can say, okay, maybe this works actually. Maybe this is the best UX because it tells the user to figure it out. So what we want to say here is, so who is the dep here? Oh, I see, solution. Let's continue. Who is the dep here? Oh, here it is. The dep is cases and the field is time complexity. Now what we want to say is, what is all fields cases? Okay, annotation. And what is the all fields for the field annotation? So we need a super class now. And what is the parent class of this? I think I know what is happening here because DSPy does this thing where it creates a new class for each code language, which is very, very annoying. This is not a code type. Here it is. Yeah, so it's code.class get item class method. Patch class gonna running on class to support. Yeah. So it's a language thingy here. Ugh. I wish they just, so how do I reach into, how do I get the code of this? Parent? No. Let's see. I'm gonna need AI here. Actually, I don't know how to solve this one. How to, can I type in, where do I go for AI search? Oh, here it is. How do I get the parent class of a class created with something like this? You guys, this basis attribute for DSPy code Python, the code class get item function because you can use basis. Okay, basis. So what? The all fields field, no, annotation dot. Yeah, okay. Basis. It's a tuple. Why? Interestingly enough, are these equal then? I think they should be, right? Yeah, so if I have, so what fields do I have? Let's see. So all fields dot keys. So if I look at the solution bases, and if I look at, there's another trickery going on here at the test bases. Okay, but are these equal in Python? Check this out, because this could be false. I think it shouldn't, but it could be. Okay. So it really is a reference to the core class then. Okay. Do I have DSPy here? Let me try some other trickery. So it's DSPy code. I see. So is this DSPy code? Exactly. It is. And it's not something else, right? No. Okay. Okay. So then I can just check. So then the logical check is if the thing I depend on is code, here it is. So what that means is if all fields if the dependency basis is DSPy code and this thing happens and the language is different, then I can raise an error. And because of how Python logicals work, if this is false, it'll exit early. So it won't try to access language, which is pretty nice. Okay. UVX, what was it? Run rough? Ooh, no. What was UV? Oh, it's UVX rough check format, I mean, a rough format. Okay, so if it's DSPy code and the languages are different, okay, now we got rid of that to do, because now we let the, okay, so now we let the thing, and we know we have a found at, so we have the location. Language is fine because it's Python, it's for the field. This is fine, right? Yeah. Location, base location. Okay, good. Okay, and finally, what I want to see is, finally, when we write this thing, how do we write it to file? Let's get back to that one. Oh, why? Ouchie. Because stuff that's not code doesn't even have a base, right? Obviously. So I'll just have to use get attribute then. Is it gonna work with a tuple? Maybe I don't want it. Maybe I should just do it like this, a tuple, okay. And then I can do if get attribute all field annotation bases with a default of none. Why? Oh, I see. It wants a string. Sorry. Yeah, so get attribute is a string. Wants the string name. This should be robust now. Okay, we made it all the way to the end, which is good. Great. And the final thing we have to do is we actually have to write these cases to file. Pred cases. Okay, so obviously it's not even in the pred. Ooh, yeah. Oh, I see. No, it's in inputs. My bad. So it's inputs. So what? I just write this? Huh. So what is this string then? Yeah, this is what I want to write in Python. Yep. Okay. Yep, this is the Python file. Yeah, it's a Not the best file, but this, yeah, so this is how I convert text to Python, which is language specific. Okay, all right, we're done then. So this whole thing should work now. Okay, we have a lot more work to do, but it's getting somewhere. There it is. So this is valid Python code. Let's see, solution. Okay, lens at nums test. Okay, tries to import it. Import. So the model is obeying instructions. Good, finally. Okay, so now we can focus on, we need to really finish the attributes. The import statements. Okay, so now this is the big thing, because it's a mess right now, and we left some to-dos though. It's not hard though. I don't think we're not going to use the relative. Let's use absolute paths. All right, so let's do the instrumentation way. Why? Because once you get it right, okay, maybe this kind of reveals what I want to do in the mid-future, but once we get this right, it becomes a really templated way to instrument any Python project, right? Because all we have to do is just look at these paths. Yeah, so let's do it this way. So can just write init.py at the current location. So let's work on instrumenting our file system a bit, okay? Very important now. So let's read these docs. What did we find last time? I feel like this is... Packages are a way of structuring Python's module namespace by using dotted module names. For example, the module name a.b designates a submodule named b in a package named a. Okay, so we want the folder that contains everything where the AI will write stuff. We're gonna call that the top level package. Now there's a problem already, because for us, we call it solution, but there's also a submodule called solution, which is not great. So let's call it workspace. Should we call it package? Yeah, let's call it package then, right? So it's very clear. And this is sort of it could have a randomized folder name too, or package name, because it's really a temporary thing. But for now, let's assume, or maybe we can just magically delegate this to the user, right? It's your job to specify what it is. Okay, so let's call it package for now, okay? And let's pull it out a bit then if we're gonna start there. So we can start working on define the package structure. Now, interestingly, package is not the right term actually, because it's for Python only. So this also reveals what I want to do in the future. If you're paying attention, what if it's not Python? How would we, I'll give you a hint, is we're not gonna rewrite all this code by hand for sure. Like if somebody comes and tells you, okay, you did all this lead code stuff and you're solving problems in Python, do it in C++ now, or do it in Rust. Everything we did kind of goes to trash, because all these import statements, like use statements, the notion of package, everything, this is very Python specific. Rust has crates, C++ has nothing. It has CMake recipes, and or it has a build system, let's put it that way. God knows how many other programming languages are there. So what I want to really do, which is sort of the mystery item here, this is kind of a spoiler, but I would like something that generalizes what we did today. Because what we're doing right now is for Python. But let's do it for Python first. But let's start thinking ahead a bit. So it's not a package structure. It is a project which, e.g., for Python, package structure. Rust has something called crates or workspaces, right? The structure is going to look drastically different. And there's no use statement. Well, there is a use. There's no import statement in Rust. There's a use statement in Rust. Blah blah blah. So in any case, what we do now is not going to work. But maybe it will if we're smart enough, and we are smart. Okay, so let's see. Project name. I'm going to call it package because we're in Python. Let's call it project folder. And I think this is everything we need for Python. If I look at the thing now, let's see, what do we need for Python? Well, I need the top level package. Init.py is static. Initialize the package. Sub packages now. We will declare sub packages. There's definitely a measurement sub package. I think that's it. I think these other things are sub modules living in the package. Okay, I have to regenerate this because it's confusing me now. So let's take this one step at a time then, right? So, okay, so now we want to modularize this. There we go. So it's project folder. Okay. Now, what the heck do we do with the sub? I think we have to, so we're touching on the other point I had, which is good. Okay, so we're working on the other to-do, which was data class for the entire file system. Okay. So let's do it this way then. How do I do a recursive data class in Python? Is that a thing? Because really that's what the files folder system, or yes, the folder system on disk is. So Python recursive data class, is this a thing? Yeah, so it's just a type annotation thing. So it would be a class called, so it would have a name attribute and sub packages and sub modules, because each package can have either sub packages or its own sub modules, where sort of which are files. Okay, pretty clear. So we want, and this, we just do this for type annotation really, right? Yeah. And do we need a default of none, or how does it terminate actually? Yeah, it is. It's all okay. So it's node or none. I think Python 3.14 does it. Let's see, recursive type hinting. I think they had something here. Yeah, there's the new native lazy evaluation. Makes annotation of corporate language thanks to full implementation of default lazy annotations. No from future import annotations required. Are lazily evaluated by default, resolving forward reference issues. Class node. Oh, I see. You can just use this. Wow. Okay, this is what we want then. Okay, good. So let's see how cool UV is then, and why we're harping on it. Because here's what I do. Well, actually, let's see how to upgrade Python version in UV project. UV Python pin 3.14, right? We don't, oh yeah, here it is. UV respectors require Python. Okay, so let's see. So if I do UV Python pin 3.14, okay, there we go. Updated Python version 3.14, and the Py project toml changes. It should. So now if I do UV sync, very good. That's it. Reinstalls everything. Okay, and I just do UV run main. And it all, there we go. It all magically works. Of course, it doesn't work because of some tiny thing here. predsolution.code. There is a difference though. I don't think DSPy works with 3.14. But anyways, let me, before we fix this, just harp on UV because you saw how easy it was. I just magically upgraded Python in my project. Don't need to install Python on disk. I don't even want to hear about that. Nobody does that anymore in 2026. So UV allows you to do everything. The problem is that I'm pretty sure I've seen this, but DSPy doesn't work with Python 3.14, which is a real shame. Let me see if I saw this. What do they have in their requirements? It should work though. Is there an issue on this? 3.14. Something is type validation not enforced. Yeah, I get 0 sync on Python. The object returned is, I see. So these are just strings. This is exactly the thing we're seeing. Yep. This error is confirmed to be caused by Python and perhaps in a different. Ah, okay. So it's exactly the lazy annotations that we need. Okay, this has been patched in development branch. Oh my God. So we need 3.10 beta 1. Well, let's do it. Let's just go do it. Forget about it, right? Let's install the dev branch then. How do I install the dev branch? Here we go. So here's how I do it. UV specify repo for package. Again, UV, right? Pretty wild that we have UV and it helps us solve everything. There we go. So UV add, we're gonna do the add. Let's try the UV add then. I wonder if it overwrites the UV add. Okay, so add DSPy 3.10 magically solves all the dependencies. I want to see if it overwrites the DSPy 3.04. I think it really should, right? Because they have the same name. So maybe it's okay. It's syncing everything, blah, 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 building locally. Man, UV is awesome. There we go. It uninstalled 3.0, upgraded JEPA 2. That's something for another time. And magically added the UV source for it. Perfect. So we are back in business. So now if we run UV run main.py, so this is insane. In 2023, well, maybe even earlier, 2022 or whatever, when UV was not popular or was not a thing, this kind of thing would have been insane. Like you would have had to write the Py project yourself, whatever. UV just does everything, which is wild. Okay, perfect. So we upgraded to Python 3.14 and to the bleeding edge DSPy, which has the lazy annotation. All this so we can do the thingy here, and we can now say, let's write the file structure class, which is really the dumbest thing ever, and it's just the data class. We have to call it package, but let's call it folder. And it has a name, str, okay, which is mandatory. And it has subfolders, which is a list of folder or none. And it has files, which are also str. Sorry, list of string or none. And this is none. And why doesn't the lazy type annotation work now? Huh. Well, this is disappointing because we did all that just for this. Which is very disappointing. Why? Oh, I see, because I didn't change my environment is stale. I have to restart VS Code. I know why. So let's restart VS Code. It's I think that's a visual bug. Yep, Python 3.14.2 now. Do I have this? I do have it. Python 3.14. Come on, pick it up. Yep. Okay, so lazy type annotation works now. Nice, 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 nice. Yeah, this would have been really bad before 3.14. Good. So we have a data class of folder. Okay, good. So now we can say, we can just, yeah, we can do the project, which is a folder. Okay. Now it has like this. So it has the name. Let's not call it package. Workspace for the AI, all right? Let's call it AI workspace. We'll think about the name more. Now, it has subfolders. Well, actually, I should put the sub files first. Or files, I guess. That makes a lot more sense, right? Yeah, because the files terminate. Maybe we need a data class for file too. So let's see. So we need a class, which is a file. It has a name and an extension. Which is py by default. It's just because we're lazy, right? So then this files is a list of files now. Oh, sorry, list file. Okay. Oh man, this lazy type annotation thing is awesome. Well, no, this one would have worked before. Actually, no, it would not have worked before because there was probably an order, maybe. Yeah. Okay, so now we're in business. We can, let's see, so we can do our files. Now, what files do we have in the top level? Well, we have one file, which is called solution. We have another file called cases. Well, actually, we should start with this because it's an input file. And we have a file called test. So how do I get these, I wonder? So if I do this project structure, I think I may see a way here. So I wonder if we should have a special field in the signature, which is a folder. And it's project. And then we reference that in our adapter. And then we're talking. It's tricky because I want this to work for any programming language in the world. Again, I'm giving spoilers to what I really want to do here, but for Python it works, for Rust it works. We know for Rust it works. For C it works. Include statements in C are not that bad. It's just include files. Yeah, okay, so it'll work for any programming language in the world that uses folder and file structures, which would really hope is any modern one. It's gotta be, right? That sounds like something sane. So if I have this, I can delete everything here. Oh, that would be so awesome if we had this special field. Except, I know what's happening. So I need to remove, okay, so our adapter needs to extract this field, not let it through the signature. And I think we saw, here it is, process signature. So the call preprocess. So this will become like the Claude Citations API field, which we discovered last time, which is sort of it's a completely separate thing. But DSPy, the way it works is it removes that as an output field because it comes in the HTTP answer. So you don't want DSPy to generate that. By the same logic, you don't want DSPy to generate a prompt for any special field in the signature. Okay, this I like now, because we get rid of the fields. Yes. Do we? We do, because we still delegate, because even today, the user is still responsible for writing fields to files. So this is not gonna matter, right? Yeah, I think this is a way better design, because it completely undercuts the need for custom fields. So then what we need in DSPy is just a thing called a custom adapter, which also sounds more DS Pythonic because its adapters are supposed to be responsible for prompt generation. So it's really, you don't want, well, it is file-aware signatures, but it's file-aware adapters. Yeah, this is it. This is the design. Okay, so then this folder has this, and then now it also has, so you just write this recursively. And yes, this also solves the, oh no, how do we solve the depends on problem? And I also have to do path manipulation somehow. So I really need a proper Python. Okay, it really feels like we're reinventing the wheel here, right? Because we don't want to rewrite the file system in a Python data class. So let's see, Python class for file. Yeah, so it doesn't have a class. So then we need to use paths here from pathlib. Yeah, this is how it is. Okay. Yep, here it is. So it's a path. And the file is also a path. I think we can delegate the extent, forget about it for now, all right? Okay, so then list of files just becomes a list of paths. Okay, the only trickery here is that these have to be absolute paths. Oh no, they don't, because I'm going to do the init method when we're talking about. I also need I need a name too, because if I use this, let me practice this. So let's say we're gonna have a new folder called workspace. Okay. Well, no, sorry, we said AI underscore workspace. Okay, then the name is just the... Okay, then the name is easy, right? Oh, it's just the dir of the path, right? Yeah. Let's see. So how do we get get directory from path Python? Get last directory name from path in a path string. Oh, it's just path name. Okay, well, it's even easier than that. So it's self.path.name. And I think this is a attribute or something. Is it a post init thing? Sorry. Python data class post init. I think it is a post init thing, right? Yeah, it is a post init. Okay. So it's and do I need this here? I see. So name str field init false. And what the heck is field? From data classes import field, right? Yeah, it's not the cleanest, but whatever. Yeah, this is the field. Okay. Okay. Yeah, so I have the path for the subfolder, so then I can extract relative to, I can always extract the path relative to the big folder name. So let's continue with the practice, right? So let's say I have an AI workspace, and I have a file called stuff.py, and I have another file called other.py, and I have another folder called internal, and I have another file in here called more.py, and I have another file called here even more.py, and I have another folder here. Well, no, I have another folder here called other internal, and I have another file called here other.py again, and I have another folder here called internal again, just to be even more confusing, and this guy has another file called other.py. Okay, so this is a pretty complicated folder structure, basically one of the more generic Python ones. So what we said we're going to do is, first and foremost, we're going to touch all the init.py files. So let's assume this is done. In each sub package, right, to use the Python language. And let's say, okay, we have to write some stuff here. So define add x and y, return x plus y. This is in stuff. In other, we have define multiply x and y, and we have return, or let's call it double add plus add. And herein lies our first problem, because define difference x, y, return x minus y. So how do we import this here? Well, we say from AI workspace dot stuff import add. Yep, that's it. So it's just, so it's package, sub package, all the way to the sub module or module. And you just import, and this should work everywhere now. Like, even if I have something very complicated, I mean, I'm not gonna bother writing all of these, but with absolute paths there. Okay, so let's do it this way. Let's say this guy has define deeply nested add x, y, return x plus y. So then we want add plus deeply nested add. So then to get to deeply nested add, you just go to it for AI workspace dot other internal dot internal dot other import deeply nested add. There we go. And then you can just do uv run AI workspace slash let's see, print double add 3.4. So we run other.py, which is this guy. Aha. So you have to do this, uv dash run minus m AI workspace dot other. There we go. Okay. So we have to run it with, we have to run the module now. And 3 plus 4 plus 3 plus 4, that's 14. Okay, so we can't run files anymore, we run modules. Okay, yeah, this is pretty clear. Okay, so AI workspace will be deeply nested like this, but this is easy to systematize. And this is how modern programming languages should really work, right? Yeah. This is gonna work for Rust, even for C-ish, yes, maybe, not really, because there's naming conflicts there, but whatever, nobody cares about C. Okay, so what we did is we wrote the inits. This we know we need to do. So let me write the steps down here then. So write init at all. Aha, and here's the trickery then. Let's do it here then. So post init should do, the class should do this, right? The file system class. Yes. So to do, right? All init.py. This is again for Python. Yeah, this is only for Python. For Rust, it's mod.rs, which is almost exactly the equivalent, except, yeah. Okay, so this guy does this. And just use an absolute import. This one becomes easy now. Based on the path difference. So what I want is, if my module has the absolute path ending at AI workspace, and then my field, my dependency, right, is deeply here, then I just take the difference between the paths and I just build the import statement from AI workspace dot, and then I string together all the difference fields, in which case this will be, yeah, because everything will be relative to this guy, right? So then I just take this guy and then dot whatever else is left minus the file name. Oh no, even the file name is fine actually, yeah. Minus the extension. So remove extension from file name, the last import path, and that's it. Then I don't know the function name because I would have to parse. So note, we could statically get the function name here if the outputs are processed in topological order. So this is another argument for the user to specify, write the outputs in topological order, which we did here to DSPy. But even if the user doesn't, we have a to-do here already. Maybe we should, no, we definitely should. Our adapter should also pre-process, and this is how you would do it, right? Through the process signature. So here is where to do. Have the reorder the output fields in topological order. That means no cycles, well, easily speaking, no cycles can exist, but maybe that's fine. Yeah, for now it'll have to be fine. Okay, quick break, pretty exciting. Okay, we're back. Okay, let's see what is happening here. Oh, gotta get the soda. Okay. So where were we? Let's see. We were at okay, so yeah, we have to progress a bit here. So so we were at the path thingies. Okay. So then this guy can just touch the initpy. Yeah, every folder should just touch the initpy once. Okay, so this one is easy, right? So it would be, how do we write the file in Python? Right, empty file Python. Oh, it's just with open, right? Yeah, okay. So we want to say with open self dot path slash initpy w as f pass. Actually, we don't even need this. Is there no way to actually touch a file? Oh, there is. Okay, it's path.touch. Okay, a modern object-oriented way to handle file paths. Okay, this is what we want. So what does it want? Self path. Okay, so self path. Yeah, we should definitely use the modern way. Okay, dot touch, right? Yeah. All right. Okay, so that's it. We have all the initpys now because everything is recursive. Yeah, we don't need this name. It's just self.path name. Okay, forget about it. Yeah, it's too easy to just... Okay, so now we can go back to our where we actually create the folder class, and we can say like this, project, which is a folder. Let's call it output. Not the AI workspace. Okay, so it has a path, which is path here. Okay. Are there no files anymore? No, there are no more files anymore. Okay, so the files are all path output. What was this? Cases.py. Yep. And then solution.py. And test.py. Okay. Then it has, we need to keep going. What else do we have here? It has the sub folders. It has one of them, and it's called folder path. So So this is at output/measurements. Okay. And it has the files. Measure. I guess there's no way to. It's obvious the files are. I'm just gonna leave it like this, but it's obvious you can post in it the files pretty easily too, right? Let's not worry too much about this though. Runtime. This one is easy to fix, and memory. And that's it. So now we have our module structure. And this automatically creates I see. So we actually have to make the thingy here, right? So make deers self.path exist okay is true. Okay, so now once we create this folder, even before the AI does anything, I mean, of course, even before, because, okay, so then we just have to write into files. The problem is, how do I know that solution is found at output? Oh, sorry, cases is found at output. I still need this field here though, right? I guess I can go by signature. Okay, so the assumption here is that these names are unique and they can be matched, right? Yeah, so I can get this name and then I can just find it here, which implies I need a search function. I think we're gonna hold off that. Yeah, it definitely sounds like we're reinventing the wheel here. Because now I need recursive search too. It's not hard, but or you can just index the file system. You can just use the okay, let's do it that way then. So index the file system. Right? So for, but even this one has to be, so if I'm in a folder, that's a subfolder actually. I can index myself, but nah, you need a parent too. Nah, I don't want to implement this. I mean, it's not that hard, but it's like you have to do the whole file system. And then you can, if we do the file system, we can get rid of found at because we can use the signature field name. We know where the file is. That's a gain. The problem is, can I ever get rid of depends on? I don't think so. And we can't use star import. We can't use all imports either. That doesn't seem safe, right? Because you grab the same function in two places. So it doesn't seem like I can get rid of this custom field. I can get rid of the custom inputs fields because they don't depend on anything, which is still half a gain. And I get rid of half of these guys, found that, which is kind of a big gain, but I can't get rid of the graph. Nah, right? It's too... I mean, not that I want to get rid of it, can I encode the graph in here? I can just have each file have depends on. And that's it then, right? Because I know the file. So how do we want the UX to look like? I think it's better if we... Yeah, I think it's better if we do it with the file way then. Meaning the data class way, because I want everything centralized. Okay, so let me see what AI thinks here. This is actually a... So we can say that, okay, we don't have fast. Trying to write Python data class that represents a possibly deeply nested file system, but with the assumption we can assume that file names are unique. This is fine. How would I collect all file names nested in the top level data class? Something with post in it, maybe. Because it structures the course community strategy that can traverse the entire tree. Here's going to property of a method. So path, files. Yeah, so I got this right. Default factory list. Cached property, all file names. Oh, that's it? Recursively collects all file names. If you have a massive tree, calculates the list immediately upon creation. If you add a file to subfolder regular property. Oh, so it's just a property. Okay, well this is pretty easy. Get names of the files, recursively add names from all subfolders. Names extend, I see. So it just caches it for every sub thingy there. Great. Can we have this return a name to path mapping too? Because I need to know the... Yeah, it allows you to retrieve a specific path object instantly if you know the name. There we go. File map. Great. Now, some files also depend on others. So what if we have a data class file with path and depends on fields? How would I collect all direct dependencies in a similar dictionary for all names? Well, this is pretty easy. Yeah, so it's just list a file. This is the wrong Python. It's not 3.14, doesn't matter. Yeah, so I can write depends on, but why cases.py? I feel like this is wrong. Depends on should be, no, depends on should be a list of paths too, right? And Depends on is a list of paths. Let me just ask for this for consistency. I'd like depends on to also be a list of paths in the exact convention as the files themselves, obviously. Yeah. Make sure this, so let's see. So do I get transitive dependencies too? I don't want those, right? So mapping. No, this is not transitive, right? Because it'll be, yeah, it's just A, B, and B, C, right? So A, B is captured here, and then this other call captures B, C as a separate dependency. It never captures A, C. Okay, good. So this, yeah, this makes sense. This is trivial then, yeah. Okay, I'm gonna take this. It's pretty elegant, to be honest. Yeah, pretty clean code too. I would have done it with post init, which is wrong because interesting. So even my so even my initialization is wrong here because post init only runs once. It doesn't run. I guess it would be just like a forced init and you would have to call it every time. The only thing is I don't know if that can be... Oh no, because it's... I don't know if you can cache things that don't return things but do... Yeah. Because this is a none, right? Well, it would have to be recursive too anyways. I think keeping this as in it is fine. Okay, so where is cache property imported from? Oh, it's func tools, okay. Okay, gotta fix my imports here. Yeah, we don't need all this verbosity. Yeah, return mapping, maps funnels, its own path objects. Okay, so now we also need these are now. Oh yeah, I need a class called a file now. All right, which is pretty similar, except it also has a depends on, which is a list of paths. What was it? Default. He used something. Oh, field. Yeah. Actually, I like the none thing more here. Okay, and then we have the files is a list of files now, and that's it. We have the depends on. We have depends on. So we just have to write depends on now, of course. So files are now files. Okay, so path depends on, oh, nothing. So these guys don't depend on anything. No, that's not true. Test depends on many things. Interesting. So this is yeah, this is why post init, I don't even know if it works here because, well, I guess, how are the inits run? They're run from the inside out, right? So the inner folders will run first. Yeah, okay, so it would have worked here. But this test depends on future things because he depends on output solution, no, cases, first of all. Depends on many things, depends on everything actually. Depends on solution and depends on both the measurements because we want it that way. It's pretty complicated. Okay, what else do we have? Measurement, runtime, sorry. Runtime depends on cases, and that's it. No, the solution too, obviously. And same for this other, for memory. Okay, this is complete now. Let me run, what was it? UVX rough format. There we go. So this is okay, good. Let me see if this works, right? So I just delete. I'm gonna delete AI workspace. I'm gonna delete package 2. Let's see if this whole sausage works because it should create at least the folder and init structures now. So UV run main. We have to also turn our thing into a module. Why? The pure path. Oh, sorry, these are files now. Obviously. I need to install Pyrite too. Okay, so we have the whole thing and we have output, init, measurements, init. Okay, good. So we have the thingy here. Okay, now this is really big because it actually does allow us to should we remove this? Is there a pre-init? Kind of tempted to remove this. Well, actually, hang on. I forgot to see the. Oh, I didn't save that chat, so that code is gone. It's fine. Is there a pre-init? No, that's not a thing, right? There's no operation I can execute right before everything. Well, I guess the init doesn't really do anything anyways, so it just assigns some stuff. I wonder if I should delete this. So if I run, which init runs first? The innermost one, it basically wipes those. Ah, this is not good at all because it wipes the innermost ones recreates them, but then it wipes the big one, including the innermost ones. Only recreates the big one. Eek, not good. I can't even delete all files because I need the init file in there. Okay, no, it's better to randomize the name then. Forget about it, right? It's the user's responsibility to just add the random integer here or something. Which, oh my god, we really need that. So let's see, if we had a name here. But how do we specify the measurements? I think it's easier to just do it there like this. And then we can just do a replace here. So this would look like, actually we can do a better replace here. We can replace this with F. Well, it can be F project name directly. And then we can have this be this. Yeah, this should be fine, right? Yeah. Don't close this. And let's see. Okay. Sorry. Yeah, we can strip this. I mean, this can just be a name. And then we can just carry it around. It seems annoying though, right? So if I give this a name, and then what? All the paths are relative to the name, or they come after the name. That's the assumption. It seems a bit dangerous. I guess I can... I can just always do self name and self path. And I can do self. So this would always be nothing then, right? It would just be name. I'm gonna leave it like this, closer to absolute paths. Yeah, because then again, we get into these. This guy doesn't know who's parent. He has a parent, and I really don't want to get into a full file system thing, right? Yeah, probably not. Yeah, let's leave it like this for now. It's fine. It's not the end of the world. Okay. Next. We got rid of this. Now this is big though, because we can actually get rid of everything. Very big. Very, very big. Because this is a complete refactoring of a thing now. So I can actually get rid of... Yeah, this I know where it's found based on the name. I know where it's found based on the name. I know where it's found based on the name. I know where it's found based on the name. And I know what everything depends on. So I don't need any custom fields at all. Okay. I think this was worth it, all right? Because I can go back to vanilla DSPy fields, which is it's a pretty big deal. We're way closer to DSPy now. Well, and we decreased our collision chances, so I don't need any of this. Yeah, this is pretty good, to be honest. It's definitely worth it. I don't need these guys. Oh, nice. I don't need the move either. Okay, so get rid of all this stuff. I don't even need custom field names. Now I do need it's all about the adapter now, which is pretty clean. I will say this. Don't even need Pydantic. Why do I even need field info? I see. Okay, so this can live in main. Okay, pretty clean. It's getting there. We'll get there. Have faith, because we will get there. Right? Yeah, this is generic. Okay, we'll get there. Okay, so now, but I need to work on the signature big time. One thing I have to do is we need to override call preprocess. So we can do it this way. What args does call preprocess have? So let's do it this way. So define call preprocess. Signature. How does he call it here? Signature, right? Is super dot call preprocess. Yeah, LM quargs. So first we can do whatever this thing does. Okay, and we can strip the special project input field from the signature. But do I need it stripped? Oh no. I think so. I think it's not that bad. We'll just strip it. So what is adapt to native LM feature? What is native response types? Interesting. Reasoning is so they separate they take the reasoning from the API here. Now this is a new one in the nightly DSPy. Interesting. This makes a lot of sense though, right? Because you don't want to force it to output reasoning. You can just ask for it and the DSPy becomes pass-through. What the heck though? So so I can just, I wonder if I can just init the adapter with the native response types. Okay, I think this may actually be very nice. Wait. Maybe I don't need any of this. Right, so what are these things? Oh, they're just types. What is a type? Oh, it's a pydantic type. Okay, so yes, I can have a pydantic type, sure. This is fine. I don't think we care about this, but yeah. From DSPy base type import type. So then our... Okay, I like this. So then our folder is a type. Which, does it matter? Not really, because maybe it will. Maybe the format method. Huh. So this is how we need to. The format method is exactly the prompt we want to come from the whole project structure. And I think that's enough, because you can just crawl the project structure and knowing the language. Okay, I kind of like this now. So what we need is... So how did they implement reasoning, for example? Or citation, sure. Individual citation, format. A dictionary for LM consumption. Dictionary to format expected by citations API. We don't care about this. No, I would like to see reasoning more, actually. Content, string, format. So it's just a print of the reasoning. Nah, I don't think this is. So in any case, why were we interested in this? Because I want to use the exclude functionality, right? So self native response types. If the field, if it is a type, it is a type, and it's, I don't know if it's it is a subclass of type. Oh yeah, okay, so I need type to hit here, okay. So I need pydantic type anyways. So it's a type, it's a subclass of the pydantic capital type, and it is a native response type. Then I get to call adapt. Aha, which is implemented for the type. If the custom type is not supported, it will return the original signature. So what? Adapt to native LM feature. This is the one that's responsible for removing. If I go to reasoning, it should also wipe it from the signature, right? Where is it? Adapt to native LM feature. Signature. Here it is. Delete field name. So, okay. So for now, we'll just use it as pass-through. I don't think it's the best way to do it. So the signature, yeah, we'll give it to the signature. Okay. But what's gonna happen is the adapter will store it and it'll just delete it in this thingy here, right? So all we need to do actually is, we don't need this to be, it's not a data class anymore. It's a proper class, which we don't care about. That's fine. We just need to implement this other method. Oh, do classes have post in it? Wait, is that a thing in Python? Oh God, please say yes. Do Python. So Python post init. They must have it, right? It's not only a data class. So can I Python inherit class to data class? Into a data class. This is what I want, right? Oh, interesting. To ensure the base class initialization logic runs, you must manually call super init. Okay, that's fine. We'll just ditch this post init then. So we'll just turn this into define write initialize modules, right? And we'll say self path init py dot touch. Well, actually we have to make the deers too. Actually, I wonder if this is that's not enough because I can't call it right. So for folder in self dot folders folder dot initialize modules. That's it. I don't need to return anything. Is this even a this is what I don't know. Is this like a cached property? I don't think it makes sense. Nah, let's not do it. And what do I have type Pydantic? So these don't even have a do I need an init here? No. Yes. I wonder if I'm gonna run into recursive, oh my god, recursive typing errors now with Pydantic. So what should I do? Just like define. No, this should be fine, right? Is this the Pydantic thing? Okay, and finally, what was the thing that I was looking at? It was called adapt to, sorry, adapt to LM response or something. And you just want to take it out of the API. Here it is, adapt to native LM feature. Because we need this. Yeah, we need this, right? I don't know, it says bool. Oh, because signature delete is a bool? No, it's not. It's just like wrongly annotated. What? Yeah, it should be type signature. What the heck is this? Wild. Yeah, we just want to delete signature, delete field name, returns the signature without the given field. So we nuked it from the field name, and then what we want to do is we need to store it here though. Because we are using this as a crutch. Okay, so we don't need this. Yeah, this is not... I can set it here, but it becomes stateful. There, so now we have it, right? Yeah, because it's the project. And then finally, we have it everywhere, right? We should also do this, which is pretty important. And it's called underscore project. And that's it. It should go away now. This we still want. We want the file adapter. Okay, let's see what we did here. Main, but I need it with files actually. Okay, this is pretty good. We're basically done now, right? So no, we're not done because we didn't hit the adapter. The adapter is only hit here when we actually do the prediction. Well, not even here. It's when we actually do the prediction. Now this is gonna hurt. Let's see. It should work though. I doubt there's any. Okay, so Kiera project. Okay, we're pretty close then. Well, not really. We didn't hit the custom stuff, but that's so why? Oh, because I don't know how to. This should be pretty easy. I don't know what signature is. It's a type. Why? So why don't I have the project then? Why is this not surviving? Uh-oh. Oh. What? I mean, sure, I can take all this thing if that's what you want me to do. Oh my god, it wants this to be a DSPy field though, right? Which is a pydantic field. feel like I'm on the wrong path here. So I'm passing a... So how can I make a signature aware? I know what's happening. Never mind. It's much easier than this. I did not pass it as the input. That's what's happening. Haha. Very good. So the funny thing is, this is wrong here, right? It's DSPy input field. Description is not relevant here, but it's... So actually I can do this, right? And I can say project. The directory structure of the generated code. Now this is not used, right? This will not, okay. Yeah, I forgot to pass it as an input field, classic. Okay, so we have the whole thingy here. So we actually need to run inference on this. So project, and then from project, did I call it project here? I hope I did. Yeah, I did. Okay, now we should be good. Should be better now. Okay. I probably still have the same signature bug. So I'm in main 28. Oh yeah, let's see. Do I have it now? Yes, I should have it. Yep, there we go. Annotation, it's a folder type, required true. It has a description. Okay. So then this will, so is it input fields? Yes, it is input fields. All right, project. But wait, where the heck is the actual value? What? I don't need it. So I definitely need it out of the signature. Oh, I need to write a custom DSPy module too? No, because I want it here though. Nah, there's something, I'm doing something wrong here. Still, because I don't need the data class type. I need the, I'm still mixing concepts, right? Because the signature has generic descriptions, but yeah, taking it out of the signature is good. Okay, yeah, so we need to take it out of the signature, but I also need a custom DSPy module that is aware how to use it. A signature is not, is it though? Because you would think the adapter, nah, I think I'm gonna do it in the adapter, right? No, something is fishy here. Which, by the way, I forgot the thing was called native stuff, right? Native response types. List of output fields that should be ready to parsing. And right, so I forgot this thing. Okay, we're getting there. Don't despair. Native response types. Folder. Okay, so this will wipe it. Okay, but is it enough? Should an adapter be aware of the runtime value of this? I think it should, because the folder structure lives in the same hierarchy as the signature, right? So it's not really runtime. It's meta info. Yeah. Okay. So I need an adapter. Okay, so I need a few. Where do we inject this knowledge in the adapter? Come on, it's gotta be here, right? Do I change the format method? That would definitely be the easiest. And then I just call format. But do I have to change the call too? See, this is so dumb because I don't have. Or do I inject this info in the signature? I think it has to be injected in the signature. Yeah, I'm just gonna do a meta field here, right? Yeah. Okay. So this is how it is. So it'll be like, I need a special quark that doesn't get like structure equals project. Can I do this? I cannot do this. Structure. Now, will this quark survive? Yeah, this is a description basically. It's not natural language, it's systematic, but that's fine. It's still at the same hierarchy as a signature. I think this is the right way to do it. Where? 275? Oh, I see. And then I don't. Yeah, this is a crutch here because I can put a none here actually. It doesn't matter. Like, okay. So the runtime value doesn't matter. What matters is the description of the field should tell you every thing. Where the heck did I get this? Why? Oh my god, why is this so bad? So I have to use the other call. So the call post process of chat adapter is not the same as the... Oh, I know why. I changed the code. This code changed. So if I look at call here, oh yeah, this is actually gone. Oh no, it's here. Okay, super call. Yeah, this. It's not changed though. Why? Where did I get this call? Where did I get the call pre-process with so many args? This is gone because we moved it. Oh, it's a post process. Oh, sorry. Oh, my bad. I'm looking at the wrong thing. Oh, okay. So this must have changed, right? In the new, yeah. Okay, this is easy to fix. Because if we look at how it's called, it should be like... This is the bad part about copying code because I'm desynchronized now. So I need to go to the call method of the chat adapter, okay, which is actually just the call method of the super. Okay, and this has changed. Yeah. And everything else is messages, inputs. Yeah, okay, this is fine. So we got, do I need project? I do. I want to see what this is. Well, the most important part is, do I have the meta info that I wanted there? Oh yeah, I forgot. This is what we care about. So self.project, very important now. See, the field doesn't survive. And for this one, I do need a custom field then. So I gotta bring back all that functionality in. Unless, who says the description has to be a string? Is that validated somewhere? What if I just have the description be the runtime value? Now that sounds like something smart, right? Yeah. Who says the description of a DSPy field has to be a string? That sounds like something very reasonable and that should be accommodated. Let's see. Is there any validation here? Move quargs. JSON schema extra. Okay. Desk KV. Desk. I think this is the hack. Oh, this is pretty nice then. It actually turns out. Oh no, don't tell me. No, because it should be extra, right, for Pydantic. I think this is it. Pretty clean if it's like this then. So we use the input field with a structure and we use it with a non-runtime value, right? So self.project. Okay. Yep, there it is. So self.project, JSON, no, it's dot JSON schema extra description. Nice. We have this is our entire folder path now. Okay. And this now gets, well, I would hope it gets removed. Okay, the other thing to check is, I should have stopped. Wait, it's easier. Actually, we should just stop here because once it's gone from here, we're done, all right? This should be gone from the signature. Okay, so let's see, process signature. It is not gone. Okay, so we need it to be gone now though, because now we're gonna have problems with that description. It's not a string. Why is it not gone though? Because I thought, interestingly, the format passed through, but that description is whack. We don't want it. So why? What is happening in my call preprocess? Is my native response types? Let me see. I'm gonna breakpoint here. One of these criterions is not hitting, but it should be easy to find out which one it is. So what do we have here? Name. Because it's an output. Oh, okay. There's a hack here then. Damn, I wish. Okay, you know what? I'm just gonna delete it then. Right, so we can do, yeah, let's just do signature equals, let's just delete it ourselves then. Signature dot delete project. Because this is what we want. When we call the adapter, it stores the metadata and then it's gone from the signature in this scope. It's still there, but it's for the adapter. Okay, and then we can ditch this thing. Yeah. So that's the only check. I don't want, the other solution is to overload it as an output field. That seems worse, right? Somehow. Yeah, we don't want to do that for sure. Okay, where is, oh, here it is. We don't need this native type, which means we don't really need the Pydantic type. And I think it's better to not use it if we don't need it, right? So we don't need the Pydantic type. And that's it. We didn't change anything else. We do need to call initialize modules though. Okay, so now we can finally move on, hopefully. So let me check that it is removed here. No, it has to be, like, there's no way, right? Because we hard delete it here. Yeah, it's gone. Okay, so from this point onward, we know the template thing, but we have this magical self.project, which has in its description, it has the structure of the folder. Finally, okay. So now what we want to do is we need to write structure dot, what is it? Initialize modules. Okay. Write the Python code file. Actually, we can do this before, I guess. Yes, this seems initialize. Maybe not, actually. It doesn't affect the LLM at all, right? Yeah, let's put it here. Okay, we don't need to make tiers. We don't need this. And finally, we just have to write everything to its place. Now, let's do this systematically. So how do we write stuff? So we can walk through this. Let me actually stop here then. So we could walk through the signature fields and just write them at their path. So we don't have to, yeah, that sounds sane. That sounds way better actually, right? Why? For folder and self folders. Because it's, I know why. Yeah, I have to use the default factory here. Oh well, whatever. Doesn't work like this, but yeah. It's default factory, right? Yeah, it is. Default factory is list. Yeah, I have to use it like this. This is not the cleanest. Because I'm iterating. I can't iterate through nuns? Yeah, let's leave it like this. It's fine. I mean, I could do if it's not none, but whatever. Okay, we're done with everything. We also wrote the output, which I think we wrote. Well, I don't really know, actually. Let's see. Did we write it or not? Let me delete this. Yeah, we wrote the output. Good, everything is good. And then what do we have in signature? Oh, we don't have a signature, sorry. Problem solving, right? We have output fields for sure. And they have keys. And we're pretty much done because if I look at, what is it called? Structure dot file map at, for example, solution, y path name f.path. So files are not paths. Oh, they're not paths. Oh, sorry. Self. No, it is f.path for each file. String has no attribute name. Did I not give? Did I not call these with paths? Of course I didn't. Okay, so the files, they have a path with path. Yeah. Okay. Same here. My bad here. Yikes everywhere, right? Okay, this can be cleaned up, although to be honest, it's pretty clean. I'm not sure it should be cleaned up. Depends on... Oh, this is wrong here. Depends on... There's two paths in here, right? I'm not sure how that happened. Yeah. There's two paths here. Actually, this is wrong code. Okay, again, yes. UVX rough format. Okay, looks a lot cleaner now. So file path, there we go. Depends on path. Good. We're really done. Sorry, we're really done now. Okay, so finally I can do like this. So what was I gonna do? What did I try to run last time? I tried to run structure dot, what was it called? File map. We're very close there. Solution. What should I do, like this? So what do I have in this file map? Oh, I forgot to take the... Okay, I gotta take the extension out here. Pathlib strip extension from f path name stem. So let's see. So let me do it like this. Structure dot files. Okay, the first file dot path dot name dot stem. No, it's just dot stem. Okay, so then I just need stems here, right? Yeah. Okay, this should really be it. So then I can just write the code now, because I know that what I want to do is for key in what was it called? Problem solving dot output fields dot keys. There we go. With open structure file map. Add the key. We're gonna write the file as f we should do this f. Okay, and we're going to say f dot write read at key, and this should really be it now. We don't need the UTF-8 because it's already there. I think this is not it. Oh, I see. It's dot code. All right. Yeah, advanced.code. Almost. Let's remove this. Oh, actually, it touched it. Okay, we're basically there. Yeah, it's done. Okay, well, this took longer than I thought, but we are very close now. This is very, very nice because we actually got rid of the... the files must be named exactly. No trickery here because it must be runtime and memory. All right. Yeah, be very careful here. Runtime, whoops. But yeah, we wrote the solution. This is it. Okay, so now it's also right. So this took a bit longer, but I think it was worth it because we really nailed it with the fields here. So we no longer have custom fields at all. My goal is to separate this as much as possible. This looks pretty there it is. So output is a full-blown Python module or package, sorry. Now, all our instructions are gone, which is fine. It's not the worst. Self.pro. Okay, let's get some instructions back. So, format output interactions. We're also missing a language, by the way. Which should be in the project, right? Because it's a project in a language. But my point is that we lost all this stuff now because this is fine, but there are no more dependencies now. Everything will hit, depends on is empty, right? Because there are no more extra fields. But it's easy now. We can just say depends on becomes, we have self.project now. So all we have to do is replace. We just have to extract dependencies there, and I hope that's easy. It should really be easy, right? Yeah. Okay, let's see where we are. So we are right in info. We don't care about info, to be honest. We just care about field. Okay, so we're in the solution field, and we have self.project. There we go. So now we go in JSON schema extra. And we go in description. And this becomes our whole info now. Okay, so we have this entire global thing now. Okay, now, how do we extract for a given field from this thing? So let's see, what do we have here? So we need to extract depends on and found at. Not sure why this is not called found at, but sure, base location. Found at we already have, depends, I think we have these, right? Because it will be info, whoops. What are those attributes called? Or, sorry, the properties. There we go, info.dependency map, whoops. Okay, there we go. So, field. Is this a logical? Yeah, okay. So depends on is just info dependency map of the field. And the base which is a list of paths. The base location is just a path, and it is the other thing called something. What is it called? Info. How do I view the... Damn, this is so annoying. I have to circle. So it's info file map. Okay. Okay, I don't need this either, by the way, actually. Okay, so more deleted code. That's good. So info file map at field tells me where I am. Okay. That's the one I want. Okay, so now I have these two. Doesn't depend on anything, no import statements. When generating the code for field, use the following import statements. Okay. Okay, so for each dependency now, its location will be the file map for the dependency. If it's a code, okay, cannot generate cross-language use statements. This is fine. I think this is it. So now we should also hit the custom instructions. Now they're gonna look really bad, but I mean, we still didn't finish them, but okay, so let's see, what do we do today? We modularize the entire project. We built a data class for the entire file system. We didn't finish the adapter, unfortunately, but it's fine. Okay, so the depth. So I need to do f dot path dot stem, right, for f in, because I need to take the stems here, and location is fine. I think this is what I want, right? It's the same stem issue we had last time. Depends on. Well, this is too easy. Oh, it's just f.stem. Base? Oh, it's just stem, right? Yeah, this is what I want it to be. Depends on the stem. Okay. I should really have it now. Okay, we're back. So, and I'm guessing, yep, there it is. Okay, so yeah. The imports are not right, but we remodularized everything to work with this new system, which is pretty big. So next time we have to finish the, okay, so we really have to finish the imports. Okay, the exclude generated code from rough is easy. We can just do it now, right? So exclude folder from rough. There we go. So rough will pass any limit pass directly. Exclude file parents to exclude MyPy cache, relative patterns to include specific file or directory. Okay, like this, right? So we just want to exclude What is extend exclude? A list of file paths from formatting and linting. In addition to those specified, exclusions are based on globs. Oh, I see. So we want extend exclude, right? Tool rough. Okay, so we just take this and we go to our Py project. And this is once again, okay, so we want to exclude output /.py. Okay. Okay. Another thing we need to do is, let's do it quick. We need to modularize our project itself. So it has an src. DSPy streaming, description, as a readme, whatever, and then we need, I believe, let's consult what is a Python project structure. What's something canonical? Well, we already know this, but actually, I'm going to run this with your library does not belong in ambiguous src or Python. Idiomatic Python. See, they want src project name. Oh, I see, because you need tests. But why not have project name directly? Well, I guess I'll do it like this. So src, then they want streaming. Well, no. DSPy streaming. Ugh, no, because this is gonna be I'm just gonna call it streaming then. Yeah, because this is gonna be annoying to type every time. I'll just call it stream then. Stream. And then we want a new file called init.py in here. And we want to move the main in here. I think that's it. We're done, all right? Yeah, we're done. History.txt. Let's see where this gets written. Right, so now when we run it with uv run -m stream.main files. Is it just stream? Is it uv run python -m stream dot main? No. Is it main? Is it src.stream.main? Is there a way to specify to UV that the src is the folder? Maybe that's what I'm missing, right? I mean, this is all nice and good. Yeah. So the paths work because we run it from here. Okay, so no shenanigans with the path, and the history gets written here. What I would like to do, the final thing, is to we also excluded it from rough, which is good, but uv src directory. Oh, like this, package applications. So what do I need to do here? What? Oh no, I need a... The source code is moved within a... Okay, so this is what we want, right? Require a package. As discussed, the Python project must be built to install. Okay, so I need an src and test. I need a build system then. Okay, so let's do it like this then. We'll just use their build system. This should work, right? I think. So then I can just run stream.main. Yep, there we go. Build stream. Okay, so this packages and builds everything. All right, we're pretty clean now. This is the cleanest you can get. So we're ready now to actually upload to GitHub too. Yeah, pretty good. Okay, so then we knocked off some more items here. Exclude generated. Let's I can do this quick then. Okay, now we're ready to do it, because now what we can do is we can just do a new file and we can call it adapter.py. Okay, and let's just move all the adapter there, and that's it. Pretty nice and clean now, thanks to the packaging and everything. So what do we need to move there? Obviously the custom adapter, which really, it's a lot of code, but it's really a lot of copied code, which is not great. Which, by the way, this is also another chance to do something else, because okay, so then we can also move some of these imports, and it's starting to look really clean now. Typing any, why did it want me to move field info? DSPy signature. What do I need chat adapter for? Okay, I can just do DSPy.chat adapter. I don't need this import. This, I think I need to move this too. Yes. So where is my... Oh, I see. So from path lib import path. What else do I need here? Aha, my custom folder structure. Now, yeah, these guys should all live here for now. Let's do it this way, right? So we have our custom data structures, pretty clean here. All these guys can go here. Okay, custom data structures, import OS. Okay. All right, so we're getting down to a clean main then. And where are we here? We are from stream.adapter import file adapter. Okay. All right. And also folder, and also file. Well, these should be separated, I guess. Stream adapter import file folder. And that's it. Our main is restored, and our adapter is... Oh, we need the base DSPy. Okay. That's it. Okay. Is it? Is there more things? No, this is it. We just have a main now, right? So what do? We take a model. We get the adapter, we configure DSPy, we define a project, and then it gets shimmed into the signature. And that's it. We solve a problem with a dummy thingy here, and we save the files. Pretty clean, I would say. And then let's try it now to run it. I see, I don't even need this field info, which is nice. Very good. Okay, pretty good. So, and then we do UVX rough format. One file reformatted, I don't know which one it was, something, this one probably. Okay, so then all the logic we wrote is now modular, very close to what I want, and we just need to fix these imports. And honestly, okay, so let's knock this one off too. Okay, so let's try, come on, we can do this, right? 10 minutes. Because it's very easy now, because the code is clean and modular. So, where are the imports? Here it is. Use an absolute import based on Python's path libs relative to. So, let's do an exercise then. So if I run Python and I do from pathlib import, God, I love UV. I can't believe we upgraded to Python 3.14 so easily. Yeah, you should really use UV if you're watching this video to this point, whoever you are. Path. Let's say I have two paths, right? So I have P1. So how are they gonna look like? They're gonna look like this. Output. They're only going to be files. So I have stuff.py. And I have P2 is path, output, some other stuff, code.py. So if I do P2 relative to P1, oh, is it not? What? Oh, seriously? Walk up equals true? Okay. But I don't need this. No. I don't need relative to. I just need use an absolute import. What am I talking about? Based on the path. Perfect. Okay, this is way easier actually than it seems. Because all I gotta do is I have P1. So I know it imports P2. Okay, so then. What do I strip from P2? Nothing. I just gotta convert the pieces of P2 to from output.sum.other.stuff.code import function name. That's it. So I go pathlib how to get all directories and file in path as a list. No. How to get all pieces of path. That's what I want. To get individual, use the parts property. There we go. So what does parts do then? Let's see. What does it do for us? P2.parts. Okay. And what does P2.stem do? I can just replace the last part with the stem maybe, right? Yeah, that should be it. And that's it. Like, parts is location.parts. Module is location.stem. Okay, so then parts is just replace parts -1 with module. Except I need a list here because the tuple is immutable. Okay. Okay. And so what do I do? So let's see. Parts is list p2.parts. Module is p2.stem. Parts -1 is module. What do I have in parts? Good. And then I do dot join parts. Wow. Okay. So from dot join like this, right? Yeah. Parts, the dot, import function name. No more field name because the path has everything. No more base location. Language is, I don't know what it is. I don't even know where we have this. So where do I use this? Generate use statement. Okay, so no more base location, and I don't even know what it is. Oh yeah, the language is Python. Yeah, obviously, right? I don't even need the base location anymore. Pretty nice. More simplification. We are ready to go now. UVX rough format. Okay, let's try it. I really want to remove this output every time. It's kind of freaking me out, but whatever. It really shouldn't, right? Let's see. Stream main with files. There we go. We forgot to write the cases. Very good. There we go. We now have a fully imported module, no leaky logic. We did it. We fixed the leaky logic in less than 8 hours. I just forgot to write the cases. So I write the output fields. Cases is tricky though, because I have to write it by hand. Yeah, so to figure out how to annotate data structures to be converted to code. This one's a bit tricky, but for now we do it manually, right? So we'll have to do, I have to do it here. So we'll have to do with open structure file map cases. Yeah, we have to do it like this, right? As f.write inputs, and it's not even this. This one is really tricky because it's cases equals this. And so what did the AI do? It did from cases, right? Yeah. Okay, so cases. And like this, right? Sorry. Okay. Yeah, so we can call this special written inputs. We can do cases. It's not that hard. And we can just go for key in written inputs. I have to figure out how to get this, which may not be the easiest thing, to be honest. And this is key equals inputs of key. Because we write the key in plain text and then we use it to index, right? Yeah. This is how it is. Okay, again. And this is big. We actually, we spent a lot of time cleaning up the code and organizing it, but this is exactly what I wanted because, wow, this is awesome because if this is the easy part, then you know what's coming next, right? So let's see, there we go. Awesome. So we have the cases, we have the solution. Our test code now imports cases, imports the function, imports the measurement, imports the peak bytes. And let's see the measurement. It even does this export thingy. So the grand test is just run output/test. Oh yeah, sorry, UV run, my bad, -m output.test. There we go. All correctness checks passed, 0 bytes memory usage. Is that true? That seems wrong. It should be 1 byte because we're allocating a unique and we're returning it. Or at least 4 bytes for a 32-bit integer? No? What's happening here in memory? I guess Python has... Well, in any case, this is not the point. The point is that there is no leaky logic. Now, this still doesn't guarantee it. Okay, so we're done. Wow, very nice. So then we're left with the mystery item. So here's the thing. We did all this for Python, okay? And we split it out nicely. And we saw that once we get the infrastructure, the DSPy infrastructure, writing the logic itself for Python is not hard at all, right? Because we know how a well-organized Python project looks like. Really, the only code we wrote is this piece. My challenge now that I want to solve is, can I write the DSPy module that writes this code? And this is what we'll try next time, right? So if I, as a human, have collective knowledge about Python, this is very easy. By that logic, this should be very easy for AI if we set up the right DSPy module, okay? So now we're gonna write this sort of nested DSPy module that generates some adapter code, that generates a method that gets plugged into an adapter. But we'll do it next time. So yeah, thanks for tuning in. That's it for today.